Welcome, everybody. I'm Jon Bach. I'm your moderator for tonight. Been the moderator for several years. It's always a fun forum for me personally to dig in, find talent. Like I found Wayne Roseberry tonight, especially for topics I haven't heard about, and I feel like I'm kind of a participant slash fan tonight when it comes to the topic. Uh, we're joined tonight by Wayne Roseberry, of course, who has been at Microsoft for 32 years until May. Now he's a free agent and looking for opportunities. Um, he's, boy, worked on so many projects there: MSN, site server, all versions of SharePoint, product support services, even assisting customers with Microsoft Office. Um, so, wow, what a storied career he's had there. And I met him on LinkedIn, and somebody I think liked one of his posts, and I started reading more about his work and was just more and more impressed at how thoughtful he was in his posts about software testing and how deep those kind of 32 years at Microsoft showed up on the site. And Wayne wound up being invited to another forum that I'm part of, where it's about 10 of us that get together every Friday and talk deeply about testing. So I got to know Wayne a lot more there, and he fit right into that little community. Um, so um, so Wayne, what I'd like to do is have you like introduce yourself, but in like the like three things in your career that have helped define who you are.
Okay. So you know my name, Wayne Roseberry. Three things that defined who I am. Well, okay. In college, I was a speech major, comp sci minor. And the thing I always said about that is that it was going to help me in the field because the computer guys can't talk. So that, it's always been a little flavor on, I think, how I approach things, even though I've spent my time on the tech stuff. The idea of sharing ideas has been critical to me in communicating. Um, Next thing that had a big effect on me was the 4 years in product support on the phone with customers all day long. I think gave me an angle on seeing the frustrations that people get into, seeing how people interact with software, when they don't have the words for it, when they don't have the frame for it, how they talk about it, how they experience it. I think that affected me. And then just so many years as a tester, getting in with MSN back in '94, and then up through that string of products where finally I was in Office. The SharePoint was a transition to the Office team, and really up until 2014, I was really a tester until Microsoft decided that everybody was a software engineer, whether you're dev or test or not. So I made that transition into dev role. But that many decades as primarily doing testing, I think had the biggest effect on me. Even when I was a software engineer, I was in the automation system for Office doing work there. So never left the testing angle, even on my software development. I think those are the three things that affected me the most.
Awesome. Okay. I'm going to take a shot at what I think. I read your paper, and I'll put a link in here, your article on LinkedIn about signals-based testing. So, all right, signals-based testing, from what I can tell, is when we use engineering and operations data in emitted by the product, is what you said, in it to find bugs by applying some workload against the product. So that, and it's this data that's radiating isn't intended for consumption by users, but instead for operations and the product team. So based on that, how is it different than like load or performance testing when you mentioned workload? So talk
Yeah,
about
yeah,
this. First, correct me on
yeah.
my impression, but talk about the signal part and its differentiation from load or performance testing.
Sure, sure. So before I do that, I'll talk about the definition a little bit. I had a definition that I originally published in the article, and then your brother James, I showed him the article, and he had some strong objections. So the definition is actually heavily wordsmithed by James because he's a master at wording things, and that operations and engineering data was really the big choice twist on it because he didn't want to confuse it with data that's normally user consumed, like things that come off the UI, text, and stuff like that. And so, yeah, it's things that the product emits for the product team or the operations team to understand what's going on. So that's the core of the signal part of it, and that's where this is heavy. And we'll get into that more when we talk about it. I really, really like, John, that you went after what's the difference between that and stress and performance testing, because anybody who has had a long career with testing and a lot of experience with testing, if you read the document, you read the approach, you're probably going to say, wait a minute, that's how we stress test a product. That's how you reliability and load test a product. And you're absolutely right. The pattern comes from it. It's I spent several years testing various server and services product, doing stress testing, performance testing, leading the efforts, leading teams of engineers, writing that stuff. So I had a background in doing it. And the pattern is the same, but instead of being pointed at reliability or performance, it's pointed at other more functional aspects of the product. So it flavors up the workload a bit differently. But it's the pattern may be unfamiliar to testers who are very much in tune with the 1, 2, 3 check, 1, 2, 3 check. You know, did this pass or fail? Did this pass or fail approach to testing? And it feels very different. But if you've done stress testing, it starts to sound familiar. So let's talk about the workload. And by workload, I just mean something that you're doing to the product to get it moving, get it taking action, you know, get it doing something so you can observe its behavior while it's doing that. And the difference that I put in this, actually, I'm gonna cheat a little. I'm gonna call it an umbrella. I'm gonna say signals-based testing might be an umbrella over stress and performance. But the difference I'm making here is that the workload is usually richer than what you will do with reliability. When you're doing stress and reliability testing, you tend to take very controlled workloads, especially, you know, like with you're stressing a server, you tend to do like a bunch of requests, bam, 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 as fast as you can to see what happens when I exhaust a resource, what happens when I take it all the way up. But the workloads tend not to be very sophisticated and very rich. They tend not to explore depth of behavior. Instead, they're mostly chasing how far will some variable go, so I can get a measurement, so I can see, you know, when I run this product, you know, right up short of the stress point, what happens to the loads, what happens to the throughput. And that, you know, it's because you're trying to take measurements with stress and reliability and stuff. Whereas with what I was attempting with signals-based testing was to get into the richer, more complex behaviors that start to look more and more like what users do and get into. And it was a response to a gap I perceived, particularly in automation, between the typical automation we see, or like smoke testing or CI/CD pipelines that are doing very simple checks. You know, do 1, 2, 3, did the thing happen? You know, open the document, type stuff, select it, bold, did it turn bold? You know, open, you know, start the app, open a file, did the file show up? That kind of stuff over and over. And it's all critical testing, really important, but it doesn't get into the nasty problems that cause instability in the app, cause failures of critical points. Those tended to require longer sessions, more complex state, more complex paths through the product. And the challenge with normal automation is that it's really hard to sustain in Oracle, right? If you're doing something really complicated what is the expected output? Well, at some point, the state that you're creating is more difficult for you to encode an expectation than you can really manage inside a very directed programming. And so that type of testing falls apart very quickly when you're trying to script it and automate it. The other aspect with it is that complexity becomes a burden on your ability to even write the code to make it happen. There's some things you can do with more data-driven or model-driven tests, where a thing can explore based on a model you create, but still the creation of that model or capability to do this taxing as well. And I wanted to look at ways of taking advantage of the automation to get into permutations and complexity that are much more expansive and much more powerful in terms of scale and scope and depth they get. But that meant I had to give up on this verification-based way of saying, is the state we're in wrong, right? Because when you're out there, you just can't track it. And when I was thinking about this, because all the apps that I was working on were going from these on-prem products to hosted live and heavy cloud-based components to them, the product teams have already been implementing a really rich data collection capability, right? With SharePoint for sure, everything was collected in services on the back end for us to inspect. But with Office, they were making these massive investments in data collection from the clients running on the desktop sent to the back end, to the cloud for deep processing by the product teams. And the product teams were building a lot of muscle and capability around looking for problems that were happening to the customers live. And so what I was thinking is like, well, what can we do with the automation capabilities to create a synthetic workload, something that is just as capable of the customer getting into complex states, and use the same capabilities we have for saying, what's the experience for the customer? Are bad things happening to them against the synthetic workload? So, we treat the automated agents as if they're end users, as if they're customers using the product, and we analyze the experience the same way, using the same tools, the same capabilities. They were calling, Office was calling that data coming back from the customers a signal, and so it's all about understanding the customer from the signal. And so I'm like, okay, well, we're making the workload, it's testing, it's directed, we're making things happen, and we're observing it to try to see if there's a problem with that signal. So signals-based testing. That's how the idea kind of formed in my head.
There was a question in the chat about a distinction between signals-based and production monitoring, and the questioner suspects this question was just answered, but it does sound very similar. And so let me pivot his question a bit and say, so is there instrumentation? Let's say you're doing production signals-based testing. So I would assume that you'd have to instrument some kind of sense of monitors to get a sense of what the workload is. Whereas pre-release, you would artificially, synthetically manufacture a user load. Is that a correct?
Yeah.
Okay.
Yeah. I'm gonna paraphrase again. So we're 2 levels of paraphrase now, and we're incepting our paraphrasing. So production monitoring, we're using the same tools and capabilities as the production system and process and way of analyzing it. But instead of relying on workload that is customers, users doing what they want to get their day done, we are having automated agents create that workload. But we look at the same data coming back, and that allows us to get ahead. In whatever delay there is between, you've got something that you can apply workload to versus the world using the product. In the case of Office, that was actually, they release every day, a new build every day to their internal users, but it takes like 60 to 90 days before the whole world is using that build. They release a new one every month. It's actually quite old. So with the synthetic load, you've got this opportunity of building up a view on the data that would be in production, but it's coming off your bots. your automation. So it's similar. It's I'm trying to leverage the what we do with production to get a look at the measurement.
So give me an example or two about a typical signal you might use.
Yeah, okay. So there were two for Office. We were two that we really looked at, and well, and I'm going to subset one of them. But the first one was the built-in product telemetry signals that are just in Office, which are mostly functional points. Like, we get this functional or the use going into this scenario, as well as heartbeat points. Like, here's a time measurement on how long something took, or here is a little health check where the app says, am I good? Or errors. The app will say, I was doing something and a really bad thing happened while I'm here. I'm telling you about it. And that goes into a stream. So that's just emitted by the product itself. There's also a stream of data that is part of Windows error reporting. All apps report if they're a Windows app that, for crashes and other such things. And those get reported up to Microsoft in general. And Office had this huge pipeline that would correlate the sessions and time and event of the crash with the telemetry data that the app was emitting at the time and stitch them together. And so we would look at, we'd look for errors that the product was emitting. We would look for performance measurements of, how long certain things were taking. We would look for just functional hits to see what are we covering with our workload. And we were looking at the crash data, which crashes are we hitting. And then there were other points too, where like I wasn't specifically looking, but a product team member, this happened to me a couple of times, our product team member would come back and say, hey, we have this error that is occurring with the customers we've never been able to nail. What makes it happen or such? But we saw it spike, and we tracked it down, and it was one of the bots that was hitting it. And we'd like to understand what the bot is doing so that we can maybe see if that's what the customers are doing to get to the same place. So sometimes a lot of those were errors that a given product team knew about, that was meaningful to them, but that I didn't know how to interpret or prioritize as such. So they'd come back to me with it. So it was a variety of things. What we were taking advantage of were things that the product team already knew how to look for. Like every single one of those examples, the crashes, there's teams of engineers, a whole crew of people that looks at that on a regular basis. So we were looking into their process. The performance team, likewise, there was a team in Office that was dedicated to analyzing performance and trying to look at in-market indicators, regressions that might be tied to given fork of the product, and like what the specific app errors, and then the coverage functional points, we were using that to try to improve the ability of our bots to plumb deeper and deeper into the app. It was like, oh, look, a new, a couple hundred showed up because the tool set learned something new. So.
And so now that you define this class of signals, you mentioned in the article of leveraging AI and machine learning to analyze that signal. And so tell me a little bit about that, like you mentioned anomaly detection.
Yes. Okay. So anomaly detection, this again, the theme of what I was doing was writing something someone else did on a lot of this. So I was just trying to take advantage of where a whole energy, money, and understanding was already going. The inside of the Office team, the group that builds the data pipeline also builds a set of analysis tools. And they have data scientists who work on ways to have insights from the tools. And one of the things that they built was an anomaly detection engine. And a product team could say, we're very worried about following event. Does it change, if we drop a new build? And the anomaly detection would, establish the baseline and then, tell you if we're seeing changes against the baseline. And they had in particular that for crashes. Are you seeing an increase in certain crashes or in just crash characteristics built. And that was, well, the moment we turned on the bots, that caught the interest of the data scientist who was working on it, because he's like, okay, we can now start to see maybe predictive characteristics. Are we seeing a crash that might we predict is going to pop up later when the end users hit the same build, and start to look at that. So we were tying together their anomaly detection engine against the synthetic workload to prioritize crashes to look at. Because
were the bots listeners, or were they generating workload?
so the bots, when I'm saying bots here, I'm talking about agents that were generating workload.
Okay.
The listeners is the when I'm talking about the data scientist, this conversation, that was like a listener, right? Something looking at the incoming data stream and applying an anomaly detection model against it. We were also using AI to drive the agents, which is that's another fun conversation. It was something I was doing for the last several years, yeah, it was using AI to automatically learn how to navigate the Office client, build a model, and then tell it to seek goals to get to other places that it learned how to get to. And that was a way of getting this constant coverage 24/7 and just scale out the load by just throwing more machines at it without having to take, engineer time to explicitly write tests. That's what I was experimenting with at the end. And that's the thing, when you see, when you're doing a very check and verification based system, it's really hard to work that way, because that kind of approach is, ahead of time where you're going to be looking for. Ahead of time what you think might be right and what would be wrong if you get to a specific thing. But when it's an AI system that's giving you the ability to scale and explore, you have to give up on that. I know ahead of time what it's going to do. And signals based is the more powerful way of saying, I found an issue. And it's really, I described this in the article, and this is the big distinction with, I think, with this kind of approach versus a more conventional pass-fail approach. With pass-fail, you have a sense of, I know it's bad because it violated good, right? If I open the file, I want to see the file there. If I switch one app to the other, I want that app to have focus, that to whatever. You've got some rule that you define. I expected this, and if it's not that, it's bad. Okay. With the signals-based approach, you have to give up on your expectation of good. It's just too much. What's good right now? I don't know. There's too many things going on. Instead, look for, I know it's bad. I see this in the stream. It's either absolutely wrong, undeniably wrong, or merits a deep investigation to see how wrong it might be, right? And so it's you've got to turn off this notion of I can check against an expected state versus I am going to look for obvious cases of wrong or disturbing analysis.
Yeah. Is one of your, you mentioned in the article events, and events is a key construct in testing, right? So do you tell me more about event as an oracle of something that you're listening for, or does it have to be an event or something that you define as an event?
Well, in this case, actually, I'm talking very specifically about terminology and technology that was implemented in Office. So in Office, the class is an event. They fire an event that
Okay.
got different names inside, but it's an event that gets fired by the app and sent through a pipeline. And when they're looking for things, they're looking for specific events. When they query the database to see, what happened, they're querying on event names and event IDs and stuff. So it's an artifact of what we named the tick inside the Office team. So it maps to broader concepts that I think people would say, what's the bigger philosophical worldwide term of event. But when I was writing that, I was probably more in mind of exactly what we called the construct in Office. Just it was a coding name.
Yeah. Okay. Because I really like what you're saying about like not like you start with something you define as bad, which by definition is a missed expectation of something that you think ought to happen or ought not to happen, based on something you think ought to happen. So it's that
Yeah.
the delta between expectations and reality, right? I guess you could say. So let me pivot my question. If I were to say this sounds really cool, I see a little bit of a distinction from production monitoring. Um, how would I? Let's say I actually ironically brought you back into Office, right? And I say,
Yeah. Yeah.
Wayne, we want to start signals-based testing at Office. Like, is there like a top three like questions you would ask me on the checklist in terms of signals you want to listen for or to start both pre and post release?
Yeah. Yeah. I mean, you just answered my question for me. It's
Yeah.
it is what do you as a product team already look for? Like if your product is in market right now and you're getting data back from the usage, whatever form that is, right? What makes you say something bad is going on? Like we've introduced a bad bug into the market, we have a regression, there's something we need to pay attention to and look at. What is it? What does that signal look like? How do you monitor for that? What are the tools you use? Okay. And then I think the next question is like, how do you feel about your ability to find those before you release? What's the kind of like base opportunity that we have on this? When you see these signals, how soon do you see them? So I'll give you an example. Inside Office, like I said, you've got these daily releases to the product team, and then about once a week to all of Microsoft, and then about a week or two later to early users, and then quite a while later released to the whole world. And that time span is many weeks long, but there are certain signals which show up really, really fast. Like if you've got something that shows up when you're released to the inside Office users, there's not much race opportunity. You can get some bots out there to try to find something before they see it, but chances are your bots may be spinning up just as those users are coming on because the process is so quick there. And so you're not really racing very much. Likewise, the release of Microsoft a week later, you can probably beat them with something. It starts to get more interesting. You're trying to beat the internal users that come a couple of weeks after that, because you can very much get ahead of them with automation, right? You say I can buy a week and a half here. If you're racing the whole world, then you've actually got quite a lot of time because of the way the model was. And what we found is that there were bugs where nobody would have any idea that they were there because users, for whatever reason, weren't hitting the patterns until it got all the way out to the whole world. It's just like all of the internal usage was great for other stuff, but wasn't showing us anything for certain class of bugs. And then you get 100 million plus users all hitting it once, and suddenly, oh look at that, And so, if those were the kinds of opportunities that I look for and say, okay, we can get ahead of that with synthetic load, right? So that's the race question. But there's the other interesting one, which is like, what are the issues that are hitting you in production, but it's killing you for repro? Like, I can't get a controlled way of having this happen. Because this is actually an important distinction between production monitoring and something where you create the workload, is you can't control what the end users are doing, right? I mean, they're giving you information that's really critical, but if someone was going out writing an expense report and some error happened that is really important to you, the product team, you're not going to get on the phone with the customer and say, hey, yeah, I know you're done writing your expense report and you've moved on to some other aspect of your life, like dinner or something, but could you go back in and do that again? Because I really want to see how this bug works. And can we talk back? That doesn't happen, right?
Yeah, good point.
Whereas if you have found that a bot is hitting the same error, then it's like, you can say, well, can we find out that pattern and spin up 1,000 iterations of it and see how often it occurs and chase it that way? Or can we get a more detailed log of what the bot thought it was doing and get by, the control by control script of what the bot said. This is what I did, and then from that get some clues. And so when it's the synthetic, the big distinction then from the production is that you control the workload.
Yeah.
The agent will do what you tell it to. And then one of the things when I was talking about signal-based testing early on, I said, so the deal is that with real users, everything they do is real. It's going to happen because it did, right? So you no longer have the nobody uses it. That's indisputable now. You've got a sense of importance because of frequency. So you've got a measurement there. So you've got those two things, but you can't control them. You can't say, go do this again. Synthetics, you don't know how important it is. The rate at which this happens is completely artificial because you made it happen that often, right? But you can try to make them do it again. You can have them repeat that as often as you want over and over. And so it creates this crisscross of opportunity where you say, if my synthetics are hitting the same thing that my users are hitting, I now know it's real. I now know it's got some value that I can assess because real users are hitting it. But I don't have the problem if I can't get them to do it again. I can try to get the bot to do it again. So that's another, it's kind of a secondary selling point. You kind of have to have the product team already bought into the whole idea, but they come up to that pretty quickly once they get it. Once they get it, they start saying, so can we get these bots to repeat that? So I think that's the third domain I go in, is to explore, I don't know, their pain, their anxiety, their pressures on that dimension to see what we can look at there.
Yeah, it does sound like that helps my model of what this is, because load testing is the kind of canonical, almost cliche of you put load until you get the failure, and then you go, okay, well, I guess we should back off that, or there's our threshold. Whereas this, you could not hit your threshold, just have the bots make a load that's within limits, but add a couple of variables that the customer is doing to find the signal in that combination. And so which is and I'll pivot to one of the questions that we have in the chat is, with respect to that, with mimicking customer user issues, data setup particularly is difficult, especially when it spans multiple back-end systems. So was this a challenge with your synthetic models?
Oh boy, it's such a complex. So yes, and such a complex one. So it depends on what you're doing. There's simpler versions of this where the bot behavior is more directed. Before I did the AI exploration on the PowerPoint team, dove all in on this signals-based testing, but they were writing scripts. They took really long, complex ones and relied completely on the signals data to tell if something's wrong instead of the end state. And in those cases, the data is not so hard. You're so directed in what you're telling it to do. The data kind of naturally falls. I wanted it to have 30 people all open a document at once and do some edits back and forth and stuff. So that's not so bad. It's kind of easier. But when you start getting into self-directed AI, there's a lot of problems that come up with data. So one of the issues is that the telemetry stream that we capture from the product doesn't tell you anything about customer data because it's compliant with privacy law and stuff. So we never say what the user type, what their data is, and things like that. So a lot of that, that's definitely lost in the telemetry signal. The bot, when it's doing things, will record what it was doing. So there's some stuff where we know, it typed in this, it typed in that. But the bots were not that rich in their data entry capabilities. So you tended to type in a lot of canned phrases. But one of the other things that they would do is, either through us directly telling them how or from them learning it, they would open files that were already on the system. So we were using live accounts. They're these accounts that were on live attendance on Microsoft.live. They're backed by a SharePoint site. So, you'd log into Word or Excel or PowerPoint or something, And in walking around, they'd walk into the file menu, and the MRU list would come up with the files that user has recently seen. So files from prior sessions, either by the bots or another test, even outside of this whole framework, might show up in the list, and the bot would open it. Right? And so in comes some file that wasn't in this session, it's from somewhere prior. And suddenly you've got something coming in, you don't know what it is from the standpoint of analyzing what happened. It's just this file open, and that file may drive a behavior that's a bug in the app, and you're like, I don't know how to get back there. It just opens a file called blah 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 dot .cx. And so that was challenging. There was also other fun challenges in some of the apps, like OneNote, for example. When you open OneNote for the very, very first time, but you already have an existing notebook that was from another machine. Okay, so you're a user, but you've switched machines, and OneNote connects to your SharePoint session. It says, "Oh, you've got a notebook here. Let me pull it down." So it pulls this whole notebook down. That happens rarely for end users, right? When you go to a new machine, and so the servers allocated to handle that distribution. With us, it happened every single time because the machines were a new office setup and wipe. So it's like a user who has prior history with the back end comes onto that machine for the first time every single time. And it goes, oh, let me download your OneNote file. And then it downloads it, and then it edits the file, which auto saves. So as we were running longer and longer and longer, the files on the back end were getting bigger and bigger and bigger. And every single session started with massive file download. And the accounts that we were using were coming out of the same market allocation as the internal Office Teams accounts, the dog food resources. And those were specifically budgeted for a certain population size. Okay. And at some point, we started overloading the download capabilities of that system because it was built to handle a team of about 7,000 to 10,000 people, and the new file, OneNote file, down was way out of balance with what normally happens, and we didn't know we were doing that, but we got a call from the OneNote team saying, "Hey, what are you doing?" And we had to we had to figure out a solution to that to get the bots to back off of that behavior. So, and it goes on and on and on. One of the challenges we didn't solve with the bots, this is more about the bots than the signals-based testing, but because it was AI that was learning how to navigate by looking at UI controls, that's much easier than thinking about what am I going to put in this spreadsheet? What should go and sell this and sell that refers this? Or if I'm doing a PowerPoint slide deck, how do all these things relate together? I'm doing animation. It's like content is so crazy rich in a productivity app. The notion of a bot learning how to create interesting, useful content was a domain really we hadn't cracked. It was mostly static stuff that we randomized behavior that it would pick from. And so the ability to explore really data-rich stuff we hadn't cracked yet. And this notion of like even cracking and say, okay, well, if we do make it capable of exploring it, how do we even capture the notion of do that again? Right? It's really rich and really complex and explosive in the permutations, and probably would have exploded the model that was backing the bot behavior in the back end. So it gets crazy complicated just about every way you think of it if you're going into this broad functional space. Usually with load testing and reliability testing, you tend to work from more canned sets of data, right? Like if you're uploading a bunch of files, you've got them in a repository, you upload the same one, same set all the time. Maybe you randomize it, but usually against a controlled distribution based on attributes and sizes. And so it's very controlled when you're doing that kind of stuff. But we were going for more stochastic behavior, trying to find things that we wouldn't find through thinking of them ahead of time. And that really makes the data problem challenging. Damien, ChatGPT can't just do it all for you. Not all of it, but I, I think an LLM would be an interesting way of coming up with content permutations. I've used it for some of my own stuff on other problems, and actually, I think there's something there, but it's hard.
Yeah, you got a few LinkedIn posts about that. I think that are pretty cool about that. All right, let me open it up to questions. If anybody wants to unmute and or turn on your camera or one or the other, um, it's your turn. Any questions for Wayne? Of course, you could also put them in the chat as you see Damien doing. Um, Happy to do that. So, any questions for Wayne?
I'll go. This is Damien. So what advice would you have like for a team wanting to explore this approach?
The first advice I would say is actually not really about signals-based testing, and it's about product signal in general. And I'm going to be really hand-wavy with it. You need to develop your product signal muscle. So there's going to be some technology you need to implement to emit a signal from your product, collect it, and analyze it. There's either something you can buy or build, but you need that there. And then you need to have practices, processes, conversation, whatever, in your team around looking at that. What do we do with it? How do we look at it, and etc. Because it's this whole approach really leans heavy on a lot of that being in place. I find that if you take it entirely from a testing angle, right, we're going to do some tests that are based on signal, and you say we'll implement the signal into the product as a testing initiative, there is a tendency to underfund and under-engineer that kind of effort because nobody is seeing it as a core business value. And I believe very strongly that effort requires so much capability from the team that the data you're collecting needs to be given the priority of business value, as in we drive the business based on what we learn from this. I think that's the only way you see enough energy and money, because this is a money problem, going into building the capability. So I feel like any attempt to come at it any other angle from just a test-only standpoint is going to get way underfunded, way under-engineered, and you're just going to be frustrated with things that don't stand up. Because I mean, I was leaning on things that had billions and millions of dollars and more like the 8 to 9 digit range, of investment that I was leaning on. Because Office is massive, so obviously not everybody needs to go in that deep. But it's I think the business has to be running on this data for you to really take advantage of it first. And I'll give you an example of where there was a big difference between teams. I'm not going to use team names on this, but I remember that I was working with a group of teams they wanted to exploit this approach for a major engineering effort that they were all engaging in together. And one team had already inside themselves built a triage process around, if we see the following thing, we're going to treat it this way. And they, on a regular basis, once a week or whatever, they would look at the telemetry stream and the issues, and they already had a notion of, if we're testing and we see this come out of it, we'll do that. And so they had a prioritization scheme, a sense of what to look for, how they talked about it. The other teams I was working with hadn't had that process yet, but the engineers were trying to get something going. And what I found is that the second group, while they were doing brilliant work on the testing side of creating workloads that did great things, there was so much effort that it took for the social cultural aspect of what do we get from this data? What is bad? What is a failure? Whereas the other team, it was like, bam, they were succeeding, pop, 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 and they were constantly coming back with, we got this out of it, we got this out of it, and it just constant success. Whereas the other ones struggled and quit for a while, shut it down for several months and come back a year later and start it up again. And so my key thing is that you need something that already is critical to the business in this dimension for it to work.
Cool. So Ken's got a question about, all well and good for big companies like Microsoft. What about littler organizations that maybe bootstrap ideas to do similar testing? Have you seen anything out there for those smaller orgs?
So unfortunately,
any tools?
Yeah, you talked about my long time career at Microsoft. I've lived in a cave for 32 years, and so
Right.
when you ask me like what are smaller companies doing, I fall short on that. I'm not really good at saying what other. However, I do know that collecting telemetry from your product, monitoring the product in market, is considered a core skill in the agile world, right? It's fast feedback, etc. So if your product isn't there, if your company isn't there, they probably already aspire to be there, but haven't seen the opportunity to put it in place. And unfortunately, I don't know the tech that people use for that well enough to rattle it off. I know that Azure has things in their stuff. I'm assuming AWS has things there, and other hosts and other backends probably have stuff. But I'm not a catalog or dictionary of the products that are in market. And so if you're small and not there yet, I think I would be putting business for reasons why you want to do it, and I would lean heavy on the degree to which your business believes it's in a fast feedback, agile aspiration. Because that's what I find is that the signal feeds that. Anybody who wants to be fast and respond quickly aspires for that, and it's probably something that's on a backlog somewhere, something they want to build. So it's a matter of where you're at as a company. Making your own thing, you can do it. You can make your own, because we had done it prior with similar kinds of things. Always seen something like that crumble as the test team tries to pivot as fast as the product team's moving. You say, oh, I'll listen to this, I'll listen to that. So you set up some listener or some data stream coming out of the product, and then the product team changes the format of the data stream, makes a completely different tech. Then you can't pivot fast enough, or you find that you're trying to maintain a pipeline that is picking up the amount of data that's crazy big, and you're spending more time maintaining pipeline stability than you've been given budget to do, right? And so this is why I believe it's got to come with a business-driven desire for the data, period, or you're probably going to struggle.
A long answer, Wayne, is finding the signal in the noise. And it sounds like this technique, you start with the signal or a very rich idea of what signals are. Have you ever done the opposite? Start with like a bug you need to reproduce, right? You alluded to this earlier in the call, but you start with what signal you're looking for, but you've got to parse through all of this noise. Is that a misunderstanding of an application of this technique?
No, it's not a misunderstanding. It's the question is how to get there. So what I was doing with the AI, it was hard to do that because of just the way the AI worked. But with the concept in general, what you might be doing is like saying, so you've got, I know this bug happens in production. How do I get there? I would say that independent of trying to get it out of a synthetic workload, team engineers are already trying to do that, right? If let's say there's some ship cert that is showing up in product telemetry, and some engineer around that feature is like, yeah, but I don't know how it gets there. well, how are they investigating that? And they're probably looking at other usage patterns that start to correlate and start to predict. And it's a lot of data crunching and analysis. So you can use it to do that.
We lost Wayne. He did say at the beginning that as you saw, his internet was a bit fragile, given his camera bandwidth, which is why I try to have my camera off most of the time. Not that that makes a whole lot of difference, but hopefully he'll rejoin and wrap us up a bit. But some good questions in the chat, and I'm like formulating this in my own head of like what this looks like, distinct from production monitoring. And it's a fascinating idea to think about what a signal is and what can be done to reproduce it and act on it.
Yeah. So sorry, I disappeared for a second while Zoom.
Yeah, no problem. Good. I'm glad you're back.
Yeah. So yeah, I'm going to go back to noise because that's what I was rattling on before. It's whether or not we're doing signals-based testing. If a product team is trying to make sense of the data coming back from their system, they've already got to wrestle with the noise signal problem. It's just intrinsic to it. There's a lot of information there. And knowing what you need to look at versus what you don't it's intrinsic to the problem. And there's a lot of tools around it that vary. I find that the more you do it, the more a product team develops tools, capabilities, and skills around it. It's an intrinsically hard problem, but it comes back into this technique because you do find yourself at some point saying, now that I see this in here, is there something I can infer from the data stream that will tell me how to make this happen synthetically? Can I backward engineer the repro from the data? I wasn't doing as much of that because the way the bots were written, but it's definitely something you see people trying to do.
Got it. Okay. So in wrapping up, Wayne, what's next for you around this? Do you want any help or thoughts, or kind of want people to experiment with this or reach out to you on LinkedIn and confer? What would you like to do next to evolve this, if anything?
I think it'd be interesting to hear other people's not just hot take on it, but sharing of stories of anything where they say, you know what, I tried something like this. And even if they talk about it just as stress and load testing, because I believe that the core skills are easily exercised there, but then extending it beyond stress and load, where you say, but richer scenario, more in-depth, more complex. And any exploration someone did, where they could say, this is what we tried, this is what we experienced, this is what we found. And it doesn't need to be big, grandiose, ambitious, like, trained AI bot. It could be less so. And it still is fascinating and rich. And definitely story about testing that are beyond the pass fail. I love the pass fail stuff. I can spend all day doing it, but it's very sad to me when we talk about testing exclusively limited to those terms, because it takes far more than that to get to some of the stuff that honestly, really, I believe is where the real threat to product value lives. Most of the pass fail stuff are things that aren't really ever going to escape into market, right? You find them, you fix them, people notice them right away. When you look at the problems your customers are having, it all comes out of things that require deeper, more aggressive testing to find. So that's why I like things that explore beyond the regular check stuff, because that's really where we make the product more stable, find the nasty stuff that actually threaten the product market.
Yeah, it's interesting. It's a kind of a nice hybrid between like full-on instrumentation of automated and scripted testing versus tool-supported testing that's very context-driven and strategic to find a particular signal or exploit a particular signal. I like that it's right in the middle there of different techniques they could leverage to work on what you're trying to find. So awesome. Well, thank you, Wayne, for being a great guest with a really super a fantastic topic that's very thought-provoking. I urge everybody to connect with Wayne on LinkedIn. If you know about any opportunities to send them his way, and I'll also be on the lookout if anybody else wants to reach out to me for opportunities and those kind of things. I'm always looking for speakers too, and had the great fortune, as I mentioned before, to run into Wayne's work on LinkedIn and then get to know him in this little mini forum and forums like this. So thanks, Wayne, for giving us your time this evening, and that's it. Any other closing thoughts, Shelley or Joe?
No, thank you so much for running the interview and for all of the information that you shared with us, Wayne. Really appreciate it.